So we told we are doing everything. When I was telling that we are doing everything in the software, I actually had lied.
I don't know what it is.
Because there is an ability for us. We had partnered with one company, and because it shares much of the financial and engineering backend with us, this is, let's say, pretty deeply our own tech. Yeah. So what we did, we made a hard disk without a hard disk. Why did we do that? Because we don't like spinning disks.
Which are local.
Good. Yeah.
Who does?
Well, somebody do.
Hey. Spinning disk vendors.
Yeah. So what we tried to do, technically we built a hardware gateway to cloud. This thing looks like a hard disk operating system. So there is SATA or SAS connector, which is number 1 on this picture. And you plug it right into your...
Supports S3?
This version, no. New version we're working on, it will be not 3.5, but like 2 form factor, small form factor, it will do that.
No, does it support Amazon S3 as a back-end cloud?
Oh, S3.
Yeah, S3, I thought yeah.
We heard SAS3.
SAS3, I heard SAS3.
Get out of storage.
And yeah, as a protocol right now, I mean, you nailed it right to the head. Right now we do iSCSI and SMB3 at these guys as a protocol, but we also we are working on RESTful API to skip the need on iSCSI and SMB3 as a protocol uplink. And we had to do that because we had not a promise, but you know, let's call them expectations from the big cloud vendors to natively support iSCSI with AWS and SMB3 with Azure. Unfortunately, it either didn't happen or happened in the way we don't like it. So we'll have to talk directly to the block object backend in the public cloud. So all reads and writes getting translated into protocol we want to do inside this one and getting wired over the connector 3.
Can't do it.
Okay, so the host talks SATA to this device.
To this device.
He's a hard drive.
And then this device connects to an external iSCSI or SMB piece of storage.
Yes.
What's the UI for telling it the login credentials?
That's a web GUI.
We have a demo in one slide, so we'll come to that.
Demo's fine.
Yeah, so that's why I wanted to show it.
Yeah.
And there's cache on the box, I'm assuming. On this, there's got to be some cache.
There is a cache, but it's not used as a cache because you don't really want. I mean, if the connector, there's a limitation of being used this one. You don't want because operating system thinks of the hard disk as something being extremely reliable in terms of the I/O. Mm-hmm. So if, for example, Windows gets a hard disk that doesn't respond for 30 seconds, either you have to increase the timeout or just marks like the disk is gone. Mm-hmm. If you have your Google Fiber having its, let's say, not the best days, you won't get the normal latency connectivity with it. That's why we are using these guys as a replacement for the spinning disk inside the configuration when the backend storage is not expected to be touched real often. So it's either the tiering configuration. So data initially hits, initially hits the flash tier, or let's say performance tier, and again then gets offloaded to these guys at the back end. So performance of the writes is not really important, or it gets huge amount of the flash cache in front of them. Dealing the operating system level should be configured. So these guys won't see a lot of stress, not because we are not very good engineers, but because we are trying to convert something which is not convertible. We are telling that WAN or wide area network is a reliable tech. I mean, it is in most of the places, but in some of the other ones, not. That's why we do not, and the company that does it, they do not sell it as an end user solution. It should be part of something different which really knows how to do this one. And we are coming to the next slide. So what we do, we take a StarWind storage appliance, and it has NVMe tier and disk tier. And we replace disk with these guys, and all the data, all the cold data gets offloaded to public cloud. What it helps to do, done this way, it means that the storage appliance get much more reliable. There are less places where it can fail because many spinning disks getting replaced with just a few electronic components that has no moving parts. Then we get the absolutely elastic storage tier. If somebody is running out of a couple of terabytes capacity, all he needs to do, he just has to go to his Amazon control panel and says, I need more storage. Click, done.
We need a bigger boat.
Yeah.
I have a question.
Yes.
So great piece of engineering. I understand what it does, but can you give me the advantages of doing this with a proprietary piece of hardware going into PCIe versus simply building a software stack into my software that would do the same thing?
Absolutely. It will do the same thing. And we also have the same software, I mean, the same concept running with our own appliances.
Right.
So if somebody doesn't want to have a lock-in hardware, he'll deal with the software. But there are some other guys with whom, let's say you have an EMC box, and you want this EMC box being replicating your data to NetApp. How are you going to do that? You'll have to. You cannot do it at the block level inside the firmware. So you'll have to install some intermediate level, use some software. They will make these two guys friends. That's one of the guys to make one of the way to make these guys friends. So you just take a couple of disks, eject them and replace a couple of disks in EMC box with these.
Except the EMC box won't load the disk because it doesn't say it's EMC.
Yeah, it won't load it.
Yeah.
Yeah, we can fake any type of the name.
Well, yeah, but the point is, no one would actually do that because anyone who has that NetApp or EMC
Yeah.
won't void the support.
Nah, that's right.
Well, that was just an example from
Yeah, no, I understand.
Possibilities are-
Now we're getting from the technology to the politics. So
Yeah.
like why somebody doesn't want to do that? Let's say somebody has a ready installation, and everything works, and he just wants to plug in this kind of thing into his working, let's say, VMware Virtual SAN implementation.
Yeah.
You can't do that because vSAN doesn't know how to talk to Amazon. And if you can do that in a different way, if you'll say, okay, so I have a backup application, VM, it will do a Cloud Connect, and it will do something, but it won't be the same. The same about like Microsoft Storage Spaces Direct. So you have a working cluster, and you want to get rid of the disk, and you want to have infinite capacity tier for this one.
Yeah.
You need to wait.
Does it support a fixed capacity? Most disks are fixed capacity. S3 is effectively an infinite store and something like
Yes.
that. So you define the capacity for the cloud disk, I guess I'd call it, or what?
Yes, you do it, and if you want to grow it, you just like you do the same thing you do with the hardware RAIDs. You chop another LAN. That's it. So there is no translation from one physical device, one physical disk. This one controller thing.
Supports multiple.
Yes, it will tell it can do 256 disks. So there's a limited amount of times you can increase the capacity.
Right.
So if somebody wants to do it like once a day, less than a year he'll be running out of options. But not many people do that.
It's exactly the reverse of a Seagate Kinetic drive. Instead of making a disk drive look like an object store, it makes an object store look like a disk drive.
Exactly.
Yeah, absolutely.
So going back to where I stopped it. So for the working Storage Spaces Direct implementation, you don't need to wait for Microsoft to start supporting cloud provider as a capacity tier, but you can do it without even asking Microsoft and letting them know what you do.
Yeah.
Because these guys, when you're talking about who's doing software-defined storage, then you actually we are not getting any political issues, like EMC won't talk to non-EMC disk, because these guys they will. Okay. Now going to the next one.
Yeah.
There will be a demo for this one.
A Cloud A is your name, or is this another company, or
That's the partner company name.
that's who makes the?
Yes. So, but again, we share most of the financial engineering backend.
And his brain. Thanks. So Anton mentioned EMC, and I'm getting into more like close to Earth scenario. We have two server 2016s, and we try to make a storage spaces direct cluster out of it without using local spindles as capacity, but rather using storage inside Azure delivered through a Clouda and presented as capacity devices. So let me just...
Almost incestuous.
So this is how you manage the device. So there is a web GUI for it, and yeah, username, pass. Now this one, when we recorded, was just iSCSI. SMB3 was in process.
Is this getting managed through the Ethernet port of the card?
Yep.
Yeah.
Yep, and these are two devices we have in Starwind in Azure. Now we connect to them.
Okay, so the device starts with the HCP and gets an address, and then I can manage
Yeah,
it?
it starts with the DHCP, then you assign an address, and yeah, start rolling. So now we're connected, and now the device starts saying that, okay, I'm a disk drive of this particular size to the system. So we go to the storage controllers, and you see that
No, it should be under disk drives. Huh?
yep, ATA, Starwind, SCSI disk device. Two of them. Two of them for multipathing. Now we have these two nodes. We have the local storage, some of them SSD1 and VME for the journal, and two Cloudas doing the storage, presented as a one disk. Now we're going to pull them. And also the properties. That's how it talks to the backend storage. Yeah. So as you can see, pullable can be converted into an S2D cluster or
These are single ported.
They're
single ported SATA devices, not dual ported.
yeah.
It's single Ethernet, so it's not like you're adding additional points of failure, right? Everything's single.
You just use two.
Well, yeah, I don't know.
If you don't want a point of failure, you're going to have two
Yep.
two uplinks to your internet, though.
Yeah, it's a.
Don't see anything on that screen.
You don't think these things won't support in 13H, would it? These things aren't going to support INT 13H, boot for booting,
Yes, you can do booting.
right? You could boot it. So,
Yep.
Can boot.
Well, you have a SCSI boot for that too. So it's,
And, well, just asking.
Booting from S3 could take a while.
I don't see that. That's not my.
not yet. Not yet.
No, that other card that I saw back way in the early 2000s was meant for that.
Instead of boot from SAN, boot from cloud.
Should be cool.
It'll be coming.
Is that possible?
Depends on
It's called
what
that-
kind of response time you want.
It's called Amazon.
Sure, it's possible.
Yeah, it's,
You can also boot by
yeah,
SneakerNet.
it's called Amazon Workspaces.
Is it just latency now? That's the issue?
I don't know
Yeah.
if you had
Primarily.
cache, right?
Well, latency and the bandwidth of your internet connection.
Yeah. If you have the express
I mean,
express
How long
route.
did it take to boot from
Maybe.
a hard drive? If you've got a 100 meg Ethernet, multiply by 3.
Yeah.
You can boot from 1 gig iSCSI today, no problem, right?
You have gig to S3?
Good.
I mean, if you do, I'm jealous.
I mean, you can get 10 gig if you're in an Equinix data center, right? 1 millisecond, 10 gig.
Yeah.
to S3.
But that's
Yeah, so now we're creating a tiered storage space out of these guys. As you see, Starwind is part of the cluster here. And we'll just create a small performance tier and leave the rest to the capacity tier. So we'll also show what happens if you just start hitting the cloud instead of hitting the local storage. So 10 gigs for the SSDs and 100 gigs for the spindles in the cloud.
Hopefully you did a quick format.
It's small enough. You don't want to format the cloud.
The whole cloud.
Whoa.
That's massive.
Yep. Here's our device. And we just add it to CSVs. That's it. Windows 2016 now uses Azure as its capacity tier. And we have a 10 gig device, so we're just going to fill up the performance tier. And show the consistency over within the tier and consistency when we go outside the tier.
This is going to the cloud right now.
So right now it's going to flash. As soon as it drops, that would be touching the cold data.
Going to local flash first?
Yeah. So there is a tiered storage space. So it's the journal is local NVMe, the performance tier is local SSD, and then the capacity tier are to a cloud devices.
The software automatically destages back onto the cloud?
Yeah.
So the bottleneck here is cloud, or what's the bottleneck right now that we're looking at?
The bottleneck you're looking at, it's purely storage spaces direct. So there is on the nodes themselves, there are no Starwind components now. So Starwind is feeding storage from the cloud, and inside the nodes, the only things are the cloud devices, showing it as a hard drive. On top, it's all S2D. Okay. So now you see it's going down to 10 meg link to Azure. So as we fill up the performance tier, it starts saying, okay, I'm running out of space, and tries to offload everything down there.
It's probably not supported, well, it's obviously not supported, but have you, just out of interest, tried that with vSAN?
Yes, and we have discussed it with guys at vSAN. They're interested in it, actually.
Wow.
Well, the reality is, as long as you run the certification program for your device,
Yeah.
VMware can do nothing, to stop you from selling this kind of thing.
Yeah.
That's why.
I mean, it probably won't get put onto a vSAN ready node, but it will be in the HCL if you can
Yes.
get it through the HCL criteria.
Exactly.
Yeah.
And if your data center happens to be on the same data center that, if in terms of physical proximity, that may get around the latency issue as well.
Yep.
Yep.